are you able to hear me?
Yes, I can hear you very well.
Okay, there are audience and delegates are sitting here. Just I came here to introduce you to this platform, to the forum.
Okay, thank you.
Mr. Martin Brunner is online right now. He's from Switzerland. So to introduce Mr. Martin Brunner, so basically he too a chemical engineer like us. For the last many years, over 35 years has been in this field. Right now he is Managing Director for Rambol AG. Rambol AG is an independent consulting organization in the world and contributed so much for the sustainable development for many clients and nations in the world, and they served as a consultants for World Bank, Asian Development Bank, and other financial institutions. They are one of the independent, very knowledgeable consultants in the field of waste management. So Martin Brunner, we are happy to be Martin Brunner part of this, this WTRT workshop, and I will hand over this mic to the organizers of this conference for the further proceedings.
Okay. Good afternoon, everybody. It is really an honor for me to be able to speak to you in this important conference. As I've been introduced, my name is Martin Brunner. I've been working in the field of waste management for the last 25 years in different fields, in biocomposting, separate collection of valuable waste fractions, as well as in waste to energy. I worked for, on the one hand, suppliers, but also been a professor for environmental technologies at a university in Switzerland during 7 years, and as Mr. Rao said, I am now managing director of Rambol. Rambol has quite an important track record in consultancy in waste management areas. One of the most important is for sure the track record in waste to energy. We have planned and managed the construction of over 100 projects worldwide, and we're also currently working on projects in the Indian subcontinent. So I'm really happy to be here, and I hope my presentation is ready now. So in case does it work or doesn't it work? That looks good. So yes, I can see it perfectly. Thank you very much. So I'm sending you warm greetings from Switzerland. This is the place I live and work, which is Zurich. You can see the mountains in the back, the lake, and most important, next please, the waste to energy. No, one back please, just the animation, exactly. What you can see within this red circle here is the waste to energy plant in Zurich. We're really proud to have a highly developed and modern plant. The title I've given to my presentation is Public Waste Management, Waste to Energy, Fairy Tales and Facts. So next slide please. So what is a fairy tale? As you might know, these are tales which are told from one person to the next. Nobody really is looking for the proof, but as everybody is telling the same story, it is believed by everybody. Next, please. So I will introduce you to some fairy tales of waste management. First fairy tale is it's possible to have a no waste society. The fact is that even nature produces waste. What you can see here are trees which have lost their leaves. Waste is defined as something which the owner wants to get rid of and which cannot be used for the initial purpose. So leaves falling from a tree are classified as waste. And the question is actually not do we have waste or don't we have waste? The question is how do we handle the waste? Waste is a natural product of any metabolism, be it a natural metabolism as nature, or be it a society. Society basically is just a metabolism too, with input, with things which are produced, and with output. Even more important that as noxious substances, pollutants, are introduced into any sort of metabolism, just think about our body, we also need a release for these noxious substances, and we need to handle these safely. So trying to bring any waste fully back into recycling is not possible. It's even very dangerous. Next slide, please. What is shown here is on the left-hand side, this is a typical waste stream. On the left-hand side, energy and raw material which is brought into society, production, and then actually from the household, when products are used, there are two possibilities. The one to the bottom is the material recycling. The one to the top is the energy recycling. And what you can see here is the numbers once in Switzerland and other hand in the European community. For Switzerland, where 50% of the waste is energy, going to the bottom, 50% is material recycling and 50% is energy recycling. In Switzerland, no waste is sent to the landfill not treated. Next, please. So, as you can see, the energy recycling will substitute fossil energy. Next. The material recycling will, the energy and material recycling together will reduce methane, mainly methane emissions from the landfill. And next, please. 1 ton of waste not sent to landfill but used in waste to energy can reduce the greenhouse potential by 2 tons. Next, please. Next fairy tale is that waste to energy is always a public nuisance, and public generally objects to waste to energy plants. I will show you some slides where waste to energy plants are placed in Europe, and the plant which I showed you in the beginning, and I will also show you more in detail, there was an extension needed and there was the financing needed, and as you might know, we have referendums on all sorts of things, and especially on major investments. And in the city of Zurich, 3/4 of the public voted for the extension of the waste to energy plant in the center of Zurich. Next, please. So this is an example from Nuremberg. You see the city, and then next, please. You see in the middle of the residential area a waste to energy plant, a plant with 3 lines and a capacity of approximately 300,000 tons per year. Next, please. This is in Bergen, Norway. Next, please. As you can see again here, the waste to energy plant, this is especially interesting because in Bergen this was a new plant which was built. So compared to other plants which had a long tradition in the center of the city, this was built new, and as you can see here on the left hand side, a lake recreation area, in the center residential area, sports stadium on the top, and the waste to energy plant nearby. Next please. This is an example from Bern, top left. Next please. Again, a plant which is in the direct neighborhood of residential area. Actually, from the plant to the next house, it's less than 50 meters, and this plant will be reconstructed, and it will be reconstructed 100 meters just on the other side of the railway tracks, as you can see top left. So again, in the immediate neighborhood of residential areas. Next please. This is one plant in Zurich with a capacity of 400,000 tons per year. Next please. You can see top center next to residential areas, and next slide please. The second plant in Zurich, next please. You can see again in the center of a residential area. I myself actually live in the top left of this slide and have a wonderful view to the waste to energy plant, and I actually don't see that this is a negative impact on neither the city environment nor the panorama. Next please. So again, this is the picture which I showed you before. Next please. The waste to energy plant in the center of the city, and next please. If you can see here, actually our offices where we work is just about 200 meters from the waste to energy plant. So this has really become a part of the city, especially because major parts of the city are also supplied by energy, electricity, and heat directly from the plant. Next slide please. Yes, many people feel that waste to energy will sort of distribute all sorts of pollutants in the air and to the environment. I think it's important to understand what heritage actually we give to the next generations with landfills. A landfill has relevant emissions to the air. On the one hand, methane, but also hydrocarbons, polyaromatic hydrocarbons, during 150 to 200 years. And what is more relevant, because it is not visible, is that it also has relevant emissions to water during 3,000 to 4,000 years. So up to the moment where the emissions from a landfill come to an environmental level which is acceptable for the environment, there are several decades which pass by. On the other hand, waste to energy, this process, which takes a few hundred years on a landfill, is actually performed within few hours and under controlled conditions, leaving residues which are stable for definitely several hundred years. Next please. Yes, I think one of the issues which is discussed very frequently is the issue of dioxins, waste to energy. What many people do not know is that actually dioxins are present in waste to a very high proportion. So that on a overall view, a waste-to-energy plant has a dischargeable and removal efficiency of 90%. What is much more problematic is waste burning under uncontrolled conditions, and one can say that 1 kilogram of waste burning on a landfill has approximately the same emissions as 1,000 kilograms treated in a waste-to-energy plant. Next, please. Composting has always been discussed as an alternative, and as I mentioned to you, I actually started my career in waste management, in composting, but what has become very clear through the last 30 years is that composting of entire waste is just not an option. Somebody once said it actually is a criminal offense to try to force plastic bags to become valuable compost. Certain aspects of the waste can definitely not be composted. What has developed very strongly, and what I fully support, is the composting of source segregated biowaste. This is an important fraction which is composted in Switzerland, and there is either the anaerobic or aerobic digestion of this waste fraction. But most important of all is the source segregation, separate collection, and then both the quality of the compost as well as the emissions from composting are controlled. Next, please. What I am showing you here is the emissions, and maybe you have seen this slide before, the emissions from waste composting, so not bio fraction, but entire waste composting. Next, please. What you can see is all these pollutants as cadmium, benzene, PCBs and polyaromatic hydrocarbons, all fractions which have a major cancer risk, are emitted mainly to the air, but also to the water during waste composting. The emissions of waste to energy on dioxins, as you can see, are higher in waste to energy. However, there is a major proportion of dioxins which remain in the compost during the process, and therefore are carried out then to, in case of use, carried out to the agriculture. Definitely today it is proven that dioxins are not cancerogenic. They are highly poisonous, but not cancerogenic. Next, please. Yes. Slowly coming to the end, I think what I would also like to report to you is that there used to be this waste hierarchy with the guiding principle that reduce, reuse, recycle, recover, and then disposal. But what is applying this very rigid principle has actually shown that in many cases environmental adverse processes have been chosen. So today it's clearly, the legislation clearly favors the most environmental sound process, which basically is the result which is proven by a life cycle assessment. So I think we just have to get away from this idea that recycling is always better. In some cases, in case of mixed plastics, for example, recycling is definitely worse and less environmental friendly than production of new virgin plastic and using the used and mixed plastic for energy recovery. Next, please. So I'm coming to the summary and my conclusion. I think what is very important is that there is not one single perfect process for waste management. It is always a combination of different processes, but it is always also contains to be able to have a up-to-date waste management, source segregation, collecting of clean fractions which then can be treated, for example, bio-waste or paper, cardboard, metals. That really makes sense. But on the other hand, we sort of need a sort of kidney in the system to get out the noxious substances, and there waste to energy definitely is a option. That brings me to the end of my presentation. Thank you very much for your attention.